So now let's look at another example. Suppose that test scores are normally distributed, right, with the mean of 72 and a standard deviation of 16. The question is, so 96% of test scores are below which value? Okay. So let me begin by, again, letting X denote test scores. Okay. So X is a normal variable with the mean of 72 and a standard deviation of 16. Okay. So just by this, we know that X is not the standard normal. Okay. So far so good, nothing is new. Right? Now let's take a look at the question. The question says that 96% of scores, right, are below a given value. Let me call that value X sub 0. So let X sub 0 denote the value of interest. Then what the question is saying is that if a score is randomly picked, right, then the probability that it is below X sub 0 is 96% or 0.96. Right? Now translating this into probability, this means that the probability that X test score is less than or equal to X sub 0 is 0.96. Now this looks new to us, right? So far what we've done was we are typically given a value of X sub 0, then we manipulate it by standardizing it and find the probability. Here is a little different. Here we're given the probability of 0.96 and we are asked to find the value X sub 0. So it's kind of like go the other way around. So let's see how we approach a problem like this. Note that X, we have observed that X is not the standard normal, right? So whenever you see a normal variable there's not the standard normal, you want to standardize it. So let's go ahead and do that. So if you standardize this thing, you do it by subtracting the mean of X and divide it by the standard deviation of X. So this becomes the probability that X minus mu X divided by sigma X. Remember that you do that to X, and in order to maintain the inequality, you also want to do it to X sub 0 in this case. Right, so you're going to have X sub 0 minus mu X divided by sigma X equals 1.96. So here X minus mu X divided by sigma X gives us Z, right? And then we know that mu x is 72, and then sigma x is 16. So we have x sub 0 minus 72 divided by 16 is equal to 0.96. Let me use z sub 0 to denote x sub 0 minus 72 over 16. Okay. Then the problem boils down to the probability that z is less than or equal to z sub 0 is 0.96. So here's the idea. As long as we can find a z sub 0 such that this probability, the probability that z is less than or equal to z sub 0 is 0.96, then we can replace z sub 0 by that its numerical value and then find x sub 0, which is our value of interest, right? So let's see how we find z sub 0. So let's go to the standard normal table and recall that earlier in previous examples, if you're given the probability that z is less than or equal to z sub 0, if you want to find this probability, you want to identify z sub 0 and then look on the margins for the appropriate values, right? For the appropriate row and the appropriate column to find the probability in the interior of the table. Right? The problem we're facing now is a bit different. The problem we're facing now is that we know the probability is equal to 0.96, and we want to find the z value that gives us that probability. In other words, what we want to do is we want to find 0.96 in the interior and then trace it out horizontally and vertically to find the two parts that make up the z value. Okay. So here we are on the negative side of the table, and if you look in the in this interior of the table, the largest value is 0.5. So this side of the table is not going to help us. Let's go to the other side of the table, which is the positive side. Again, we want to find the probability that we want to find the z value such that the probability that z is less than or equal to z0 is 0.96. Okay. So you want to go into the interior of the table and look for 0.96. If you look here, we're going to have 0.9554, 0.9564, and so on and so forth until you get to 0.9599. Then the next entry is 0.9608. So 0.96 is not technically in the table, right? If that's the case, we go to the next closest thing. And the next closest thing to 0.96 is 0.9599, right? So we know that this is the value that we want, right? In order to find the z value, you want to trace it horizontally to get 1.7, and you want to trace it vertically to get 0.05. And so the z0 that we're interested in is going to be equal to 1.75. Okay. At this point, you should maybe you should pause the video, rewind it if you want, and make sure that you understand what we're doing here. Okay. So let's go back to our problem. We know that a z value of 1.75 gives us the probability that z is less than or equal to z0 of 0.96. So in order to find x sub 0, we just need to replace z sub 0 by 1.75. Okay. In other words, 1.75 is equal to x sub 0 minus 72 divided by 16. I'm gonna let you do the math here, but you should find, well, let me just do it. It's rather easy. So you multiply both sides by 16, right? So 1.75 times 16, and then you add 72 to both sides. If you do that, you isolate on the right hand side x0 by itself and all the numbers on the left hand side, and so you can do the math, right? So if you do the math here, you're gonna get 100 as the answer. Okay, so what does this mean? This means that 96% of the test scores are less than 100. Okay, so in this video we looked at an example where instead of being given a value and find the probability, we're given the probability and we need to go backward and find the value that gives us that probability. Okay. So this is not a straightforward problem, so not something that we have been used to, so make sure you can do this kind of problem going forward.